Okay, so last time the work is equal to force times distance we did. Work is F times S. F is the force and S is the distance moved in the direction of the force or opposite to the direction of the force. So work done against the friction is force of friction times S, right? This one. And work done against the gravity is mgh. Like we are going upwards, so that is the work done against gravity. So, and potential energy we discussed last time that it is equal to mgh. So this potential energy is actually gravitational potential energy. But since in our mechanics we have only one kind of potential energy, so usually we will not specify that it is gravitational potential energy. So we will simply write it as potential energy. Okay. So wherever in mechanics paper you have potential energy, it means it is gravitational potential energy. Okay. So then today we have a kinetic energy. So the energy due to the motion of the object is called kinetic energy. So let's assume that there is a horizontal surface as shown here. So it's smooth. An object is placed at this point. It is moved to some other point. So at this point its speed was u meters per second, and when it is moved to this position its speed is v meters per second. Okay, so the speed has changed. So we can find, it means there will be different kinetic energy at these 2 points. So the definition of the kinetic energy, that it is energy due to the motion of the object. It means due to its speed. If speed is zero, it means obviously there will be kinetic energy zero. Okay, so objects at rest has zero kinetic energy. Objects at rest has zero kinetic energy. Okay, so formula for the kinetic energy is half mv square, mass times the speed square. If it is velocity, we take the magnitude of that velocity, so that will be speed. Okay, so at point A, the kinetic energy will be half mu square, for the speed at A is u. Similarly, at point B, the kinetic energy will be half mv square. Okay, so at rest, the kinetic energy will be zero, and the reason is because the speed is zero. So half mass times zero square will become zero. Right? So then change in the kinetic energy. When it moves from point A to point B, so what is the change? So change, as you know, it is always the final value minus the initial value. So it means that it will be the final kinetic energy minus the initial kinetic energy. And we denote it with delta KE. So KE is for the kinetic energy, KE. And change will be delta KE. So change is always final minus initial. So it is KE final minus KE initial. So if you replace it with its values, so it will, for this situation it will be KE at B minus KE at A. So it means it will be half mv square minus half mu square. Okay. So change in kinetic energy is half m. If we take m and half common, so it will be half mv square minus u square in bracket. So remember, it is not equal to half m into v minus u whole square. Okay. So see, this is half m is common. So inside is v square minus u square. So you can do this as a short working. But remember, this is not, this will be wrong if you do it half. Difference in the speed and then squares. So this will be wrong. Okay, so this is a change in the kinetic energy. Similarly, in the potential energy case, we found that if this object is taken from the ground level to some certain height, B position, which is at a height h meters, so the potential energy, change in potential energy will be the final potential energy minus the initial potential energy. Potential energy final minus potential energy initial, right? So potential energy final is potential energy at B minus potential energy at A, because it is moved upwards with a constant speed. So final potential energy is mgh, and initial potential energy will be mg times the height of A, which is 0. Okay, so but generally it will be the potential energy at B, mgh of B minus mgh of A. Similarly, mg we can take common here, so then it will be height of B minus height of A. So change in potential energy will be mg times the difference of the height. And if it is going up, so change will be positive. And if it is coming down, so change will be negative. So change can be positive or negative in both cases for kinetic and potential. Okay, so when change is negative, it means there is a decrease in that value. If change is positive, it means there is an increase in that value. Same like acceleration. Acceleration positive means speed is increasing. Acceleration negative means deceleration, which means speed is decreasing. Okay, the same concept is for the change in kinetic and potential. So if potential energy is 0, it means that object is not changing its height. It is moving on some horizontal surface. If kinetic energy is 0, that means speed is constant. It is going anywhere, up, down, left, right, or some inclined plane, but going with a constant speed. Then change in kinetic energy will also be 0. So change, kinetic energy 0 is a different thing. Change in the kinetic energy is a different thing. Okay. So I will write here, change delta KE is 0, means uniform speed, means there is no change. And KE0 means that no motion, it is at rest. And PE0 means, PE means gravitational potential energy, that 0 means that the object is at the 0 level, it has at the 0 height. Okay, so object is at 0 level. We don't say the ground, because sometimes we will not take the ground, we will take some two different heights. So then we will define the 0 level in that situation. About this we will talk in more detail later, that what is the 0 level. In this diagram, the 0 level is the ground. Okay, so this is the 0 level. So usually in the question statement, the lowest position we take as the 0 level, so that the potential energy remains positive for all the positions. Okay, so potential energy 0 means that the object is at the 0 level. 0 level means that 0 height. And delta PE is equal to 0 means something else. This means that object is moving horizontally. It is not changing its position, its height. It's changing the position but not changing the height. Height is constant. So that's why final potential energy and the initial potential energy will be same. So change will become 0. It means that horizontal motion. Okay, so remember these facts. These are about the potential energy and these are about the kinetic energy. Okay, so change in potential energy is this, mg we can take common, and then what is after this? We have some practice exercises to do. See, this is a inclined plane. So an object is placed whose mass is 2 kilogram at the bottom of this inclined plane at position A. Position B, the end of the inclined plane, is at a height of h meter. It is the direct vertical height. It is not the path AB. It is the height from the ground level. So the distance covered is 5 meters. So it has moved 5 meters from this point to that point. Okay. So let's assume that at A its speed was 3 meters per second, and when it reaches to the point B its speed became 8 meters per second. So its acceleration. So this is the situation. Okay. So we have to find what is the change in the kinetic energy and what is the change in the gravitational potential energy. So it's very simple. So if the angle is given, angle must be given. So this angle is 30 degrees. So we can find this height h. H will be 5 sine 30. Okay. So find the change in the potential energy and then find the change in the kinetic energy. So first, change in the potential energy. So we know that it is mgHp minus He. So mgHp, so delta PE is equal to mg into h of B minus h of A. So it is 2 times 10 to 20 into h. H is 5 sine 30, which is 2.5. Since it is exact, so I found in decimal. If it is not exact, so either I will write in third form or I will write in fraction form. I will write in sign notation. And at the end I will use the calculator. Okay. So HB is 2.5 minus HA is 0. So here we have taken this as a 0 level, the point A. This is the lowest position in the question. So it means that the final answer will be 20 times 2.5. So what will be 20 times 2.5? 50?
Yes, sir.
50, so that joule is the unit. Okay. mg is Newton and height is meter, Newton meter. So it is joule. Energy and work has the same unit. That's why both are transferable. Okay, so this is the change in the potential energy. So change is positive. It means that the object is increasing its height. Okay, it's true because it's moved from point A to B and B is higher than A. Okay, so it means this answer is 50 joule. Okay, now the change in kinetic energy. We know that the change in kinetic energy is half m into v square minus u square. So it means delta KE will be equal to half into 2 into 8 square minus 3 square. So then it's this is cancelled, 64 minus 9, which is 55. Okay, so this is 55 joule. So see, it's a simple question. Speed is, now see that speed is increasing and the height is also increasing. It means that the total change in the energy is 105 joule. Okay? So it means that some force is doing this work, 105 joule. So it means it needs some driving force which is bringing it from point A to point B. Okay, so if the change in the energy is zero, it means no external force is applied to the object. So object is in the free fall situation. So we will use this fact in our main questions when we start the past papers. So just I am explaining so that you remember. Okay, so see that this kind of question we can also do by using the forces which we did in the previous chapters, like find the driving force. So now using the energy, we will also find the driving force in our next section. Okay, so this